Okay, so good morning, everyone. I think we can start the Ethernet e-research Hackfest. First of all, welcome to be here today. Okay. May I? Okay. So good morning, everyone. Welcome to the Ethernet e-research Hackfest. We have a quite intense program in the next 2 weeks. Before starting, I would like, since I know very few of you, I would like to start a self-introduction. So I will move this microphone and you just say your name and your affiliation, okay? So that at least we know your names. So I would start from here.
I'm Dunkwana from Ulaga University.
Okay, you can pass by.
Yeah. Hello, I'm Mario Torrisi from Catania, from the Department of Physics and Astronomy of Catania.
My name is Patrizia Strino. I'm the CEO the agency PI4.
Hi, I'm Rita Riccioli from Catania.
Hello, I'm Domenica Marchese. I'm a doctor in communication and I work for PI4.
Good morning, I'm Margaret Kfreur. I'm an integrated expert at Education Strategy Center here in Addis Ababa.
Hello, I am Helena from Ethernet.
My name is Bahailu. I'm from Education Strategy Center.
My name is Ephraim from Ethernet.
Okay, my name is Laun Tadasa. I'm from Ethiopia Civil Service University, Senior Application Developer and Administrator.
My name is Roger Mulgeta. I'm from Ethernet.
I'm Akwaran Getacho from Ethernet.
I'm Yuel Mulatu. I'm from Ethernet.
I am Yarid. I came from Ethiopian Civil Service University. I'm an e-learning expert.
Okay, my name is Vitor Joseph. I came from Ethiopia Civil Service University, e-learning expert.
Okay, and I'm Roberto Berbera from the University of Catania, and I'm the technical coordinator of the SciGaia project. Last small thing before we actually start. At this URL there is the program of the Hackfest. All the lectures, all the materials will be uploaded on this. So take note of this URL. Bookmark it on your computers, on your browsers. And if you haven't done it before, go to registration form here and register. We need to know all the registrants. We need to register all of you in case we need to send you communication and emails and support answers to your questions. So bookmark this and register, I would say, by today. During the registration form, you will be asked for GitHub account and ORCID ID. So if you don't have a GitHub account and you don't have an ORCID ID, in the registration you will see the URLs to GitHub and to ORCID. So register there, get your URL, get your username, and then go back here and register. In the same page, you have timetable. So if you click on timetable, and then you scroll down, you have the program of the Hackfest. So today, tomorrow, Wednesday, Thursday, Friday, and so on. Okay? So, and you will see that we already uploaded slides and already put links to examples, code repositories, and so on. So this URL up to here, this one will be your best friends in the next couple of weeks, okay? And even later, because all the materials will be available there. Okay, so I think that we can start. So I want to start my presentation here, which is about, which is about the SciGaia project and the introduction to the Hackfest. So I'll give you some background. Then I'll go through the SciGaia project. I'll provide you some general information about the project and some results we got so far. Then I'll discuss I'll show you some introductory notes on the Ethernet Research Hackfest. I'll tell you how this will work in the next couple of weeks, and then I'll come to the summary. So several EU-funded projects have targeted Africa and have investigated e-infrastructures, the possibility and actually the will to build e-infrastructures in Africa. And these projects have made significant step towards the development of an African e-infrastructure. We already have in several countries certification authorities and identity federations. And these are operated by several African national research and education network. Then we had the first Science Gateway. I'll tell you what a Science Gateway is, and it's actually one of the main services we'll be explaining and using in this Hackfest. So we already demonstrated this in a previous project, and we integrated in this Science Gateway several applications used by several communities of practice in the continent. So this picture, this text will give you some references on previous projects. All the names are actually links to websites of projects, so you can visit those websites and get information on the project. So SciGaia, I would say, builds on the results on many other projects, namely EI4 Africa, and you see the time frames of those projects: Chain and Chainreds, PERIP, Arena for Africa, EI Africa, EPIC, and so on. And the partners of the SciGaia consortium, you will see them in a moment, significantly contributed in key projects supporting the development of ICT in the continent, strengthening the cooperation between Europe and Africa. So Africa Connect and now Africa Connect 2, aiming at building a worldwide backbone, network backbone. The FIS project was actually the feasibility study for Africa Connect, Euro-Africa P8, Euro-Africa ICT. So I would say in the last 10 years or so, several projects have addressed the problem of promoting ICT in general and e-infrastructure and research networks, more in particular in the continent. So SciGaia. SciGaia stands for Energizing Scientific Endeavor through Science Gateways and E-Infrastructures in Africa. Is a coordination and support action funded by the European Commission in the context of the Horizon 2020 framework program. We started the 1st of May 2015, so we will finish in 2 months from now, 2 months and a half. And the project is led by the Brunel University London, and we have key partners from Africa and Europe. In Africa in particular, we have the two regional research and education networks, namely the UbuntuNet Alliance in the southeast part and WACREN in the southwest part. Then we have, as African partners, the Council of Scientific and Industrial Research, South Africa, and the Dar es Salaam Institute of Technology, Tanzania. And then we have European partners, my university, University of Catania. We have the KTH, the Royal Institute of Technology, and the Karolinska Institute the last two located in Sweden. So you will see there links to the project web pages where you can get more information on what I'm saying. So the main aim of SciGaia is to create a sustainable foundation, educational material and procedure for the development and management of science gateways and e-infrastructures. And we have 4 main topics that are mapped on 4 work packages. So we support, we promote the uptake of science gateways and infrastructures in Africa and beyond, and this is the theme of work package 1. Then support new and already emerging user communities, work package 2. Strengthen and expand science gateway and infrastructure related services, and this is work package 3, and training and dissemination for long sustainability purposes, and this is work package 4. And the hackathon is part of basically all this work package. This is, what the concept of the Hackfest was conceived in work package 4, but it impacts on all work packages of the project. So before we go on, we already presented the concept of a science gateway. So a science gateway, is widely adopted, a definition made by the TerraGrid project in the US a few years ago. So a science gateway, that is also known as virtual research environment or virtual lab, is a community development set of tools, applications, and data that is integrated via a portal or a suite of applications, usually in a graphical user interface, that is further customized to meet the needs of a specific community. So whatever high-level portal or desktop or even mobile application that is used by a scientific community, that includes applications needed by a scientific community, is a science gateway. So science gateways leverage large-scale facility to increase access and enable collaborations. So we will see science gateways using cloud infrastructures. We will see science gateways using, not only see, but you will be also using them. Science gateways using grid infrastructures, and also science gateways built for educational purposes. So for more information on science gateways, you can visit the website of the International Coalition on Science Gateways, which is an initiative trying to build or try to gather all the information about science gateways, science gateway activities all over the world. So now I want to show you the SciGaia work packages and the results that we have achieved in the last almost 2 years on the project. So work package 1, which is about user support. The main aim is to create science gateway and infrastructure development guidelines and materials for African entrants and communities of practice. Create science gateway and infrastructure development guidelines, monitor the successful implementation and uptake of infrastructures in Africa, and ensure the interoperability and interoperation between Africa, European, and other infrastructures emerging in other regions of the world. So this is what we have done. We have on a website there. I think I can use these. Yes, we have a website there where you can get links to different guidelines and guides. So we have, concerning the infrastructure development guidelines and material for entrants and communities of practice, we have guides for application integration and delivery, open access repository deployment and configuration, and infrastructure development guides. All the code and the documentation are available on GitHub under Apache 2 or Creative Commons license, and the documentation is also automatically generated in multiple formats. So you will get some training material for the Hackfest, but the training material for the Hackfest are based on this. So this is the main source of information about the training material and the material for the Hackfest. Concerning Science Gateway Development Guidelines, we have guides for Science Gateway installation and configuration, Science Gateway integrated development environment, installation and configuration for developers. Science Gateway virtual appliance. So you can download the virtual machine containing the Science Gateway. You can install, you can replicate, you can clone, whatever you want. And then we have Science Gateway web applications development guides. So if you want to integrate your own application or the application of the community you are supporting in the Science Gateway, this is the place to start. The training material is also organized in courses. We ran several courses. The first one was an online course that we call the Winter School. We did this 1 year ago. And the training material were organized in lessons. So we had course prerequisites, Science Gateway development, portalet development, and all this. And we also have courses more related on e-infrastructure services. This is a special course that we created in collaboration with GAR. GAR is the Italian ENREN, the equivalent of Ethernet in Italy. And we built with them a course on how to turn web-based services into service providers of identity federations. So if you have a portal and you want to enable federated access to your portal and let the portal, let users of your country, of your community, accessing the portal using their federated credentials, so the credentials stored at the identity providers, this is a course to do so. All the training material are available on our open access repository, the slides and the videos of the lectures, and slides and video lessons, and each open educational resource has a digital object identifier. So you can cite it, you can find it, you can discover it, and you can reuse it. Everything is released under Creative Commons, so you can rearrange the way you like most. Of course, besides this, not only organized in the open access repository, but the material have been organized in a real course using an online course system based on OpenEdX. OpenEdX is a course platform especially suited for MOOCs, for massive online open courses. So the course is there, and we have all the video lectures and the exercises. And you can enroll the course at any time and follow it. Concerning the monitoring of the implementation and uptake of infrastructures, we created a survey that is open since more than a year, and you can go there and, for example, describe the e-infrastructure, the Ethiopian infrastructure, the Ethernet, and just to list for example, the needs and the components of the infrastructure. So you are all invited to visit that website and fill the survey. Concerning the interoperability, one key issue is to create e-infrastructure in Africa that are interoperable with the same in Europe and in other regions of the world. This is possible through the adoption of standards. So we created what we call the Africa and Arabia Regional Operations Center. This is an entry point to install middleware, to participate to the operation of the continental infrastructure, and to ensure that whatever you install on your infrastructure is based on the same standards as the infrastructures in Europe and the other parts of the world. So we have agreements with sites, and the collaboration at the continental level is driven by the 3 regional networks, namely ASREN in the north part, in the Arab countries part. ASREN stands for Arab State Research and Education Network, UbuntuNet Southeast, and WACREN Southwest. And so the African Arabia ROC provides support to sites wishing to integrate their services into the global infrastructure, cloud services, high-performance computing services, even small clusters. So if you want to join this infrastructure, the African Arabia Rock is the site to start with, and to get your site shared with the other site, and of course the possibility for your users to use also other resources in Africa and elsewhere. We have certified grid sites in 6 countries: Algeria, Egypt, Kenya, Morocco, South Africa, and Tanzania. And so, if there is interest and you have resources and you want to share them, we can also help you and support you to enable shared resources in Ethiopia. Concerning cloud interoperability, we support some worldwide standards, and we are interoperable with the EGI Federated Cloud. EGI Federated Cloud is the largest research-oriented open cloud for science in Europe. We provide cookbooks in our engagement page, and we are also able to exploit private resources coming from private companies. We are using resources from private companies that are sharing their clouds for not-for-profit projects. So, concerning now work package, this was work package 1. Work package 2 is about community. The objectives are to identify, promote, and support the cooperation between application facility service providers and associated end users, identify innovation experience maybe in the supported African user community, ensure models for sustainability, ensure the global interoperability, and identify the needs for planning, development, and coordination of policies, programs, and contents. So, for this, we have created a web forum. All of you are welcome and invited to register in the web forum. This is the link to the web forum, and the web forum is meant to be an open environment where to discuss open science, open access, training and education, identity federation, science gateways, applications, funding opportunities, job opportunities, and much more. The forum is registered in several identity federations and also in the EduGain interfederation at the global level, so you can enroll with your federated credentials. One of the objectives of this Hackfest is to create at least one identity provider in Ethiopia, but waiting for this, we offer a free access to a catch-all identity provider. So you will be invited to register to the identity provider, get federated credentials, and then access the discussion forum. And you will be guided today and tomorrow how to do that. With the same credentials, you will also be able to access all the other services of the SciGaia Open Science Platform, Science Gateway, Open Access Repository, and so on and so forth. The SciGaia, the web forum has been delivered by SciGaia, but it's open to projects. So we can even create discussion pages for Ethernet-specific topics or for Ethiopian research-specific topics. So we are already hosting the discussion of several other projects, and discussions can be public or private. So it's something that we can easily customize for you. That's the infrastructure discussion forum. It's based on this course, which is de facto standard, a framework for web forums. It's an emerging very nice. I mean, it works like Twitter. You can tag people, you can add links, you can embed whatever you want. Concerning the community, this map is not complete, but you can already see the communities that we are supporting all over Africa. Each marker is one application, one supported community. And you see the same color means that the community is spread across the continent. So we aim at putting a few markers in Ethiopia here and support scientific and research communities in the continent. So if you go to this page and you click on the marker, you will get redirected to the pages describing the use cases and the applications for those communities. But I'll tell you more on the communities of practice that we are actually supporting in a presentation tomorrow afternoon. Okay, so I won't say more on this, but I will describe the use cases, the scientific use cases that we are supporting tomorrow afternoon. Concerning now our package 3. Package 3 is about deploying services, standard-based services, enabling an open science platform. So expand and extend activities carried out in past projects, especially in deploying open linked data repositories, for not only for documents but also for data, and compliant with international bibliographic standards and international guidelines for data sharing and interoperability. And another thing is to combine open access repositories with science gateways in order to deal with very important topics as discoverability, reproducibility, and extensibility, I would say reusability of science products. So the possibility that you can access not only papers but also data, and you are able to reuse this data to tackle different use cases or more complex use cases with a multidisciplinary approach. This is the SciGaia Open Access Repository that contains all our material, including the training materials. It supports federated authentication, and resources can be manually uploaded or automatically harvested and ingested. And we developed several, the open access repository is based on a software that is called Invenio. I'll show you in the next slide. And we added more functionality to the standard Invenio release, to the possibility to mint, to allocate DataCite digital object identifiers, to establish direct links with Google Scholar or Altmetrics, and to have metadata that allow you also to provide information about the projects that, the projects that have funded specific research product. By the way, this will be shown tomorrow by me and by Bihailo. Ethernet has a clone of this that has been done using the Hackfest in Lagos in November. So other clones can be done if they are needed, but you have an exact clone of this, and you will be able to interact with this open access repository in these 2 weeks. Concerning the certification, so certificates are very important. If you want to protect your website, you need to put a certificate on top of it and use SSL connection. HTTPS connection is mandatory when you want to, for example, enable federated authentication on your portals, or when you want to build identity provider. So in the context of this activity, we established we actually renewed and extended an agreement with Comodo. Comodo is a commercial certification authority. Is one of the certification authority whose certificates are automatically recognized by web browsers. So are not self-signed certificates. So if you go to an HTTPS website protected with a Comodo certificate, your web browser will show you the little lock and will tell you that the site is secure. So we established an agreement with them, and under this agreement, they are giving us 5,000 free certificate per year. This means 5,000 certificate for 1 year, 2,500 certificates for 2 years, or 1,667 certificates for 3 years, or any combination of the above. So we are empowering NREN representatives as registration authorities. So people at Ethernet can already use this and request a free certificate to protect services in the country. Concerning federated services, we are supporting the deployment of several services, portals, collaboration portals, educational repositories that are part of identity federations. So you see there the country, the identity federations, the identity providers we support, and all the service providers that we have been supporting. In this list are missing the open access repository and the server for MOOCs that we built in Ethiopia, and we want to protect this. Maybe we can do this during the Hackfest. Concerning applications, I already told you that we have this general purpose demonstrative science gateway, and in this science gateway we have several applications already available. Some of them are general purpose, like Octave. Octave is a clone of MATLAB. Or R. R is a well-known package, open source package for statistics analysis. And we have many other applications from bioinformatics, from earth sciences, data management. So you will be able already to access and use this, but you will be tasked during this course to develop applications and include in the Africa Grid Science Gateway. This is the Africa Grid Science Gateway, and it supports several identity federations and many identity providers, also from Africa. So one of the objectives of this course is to create an identity provider for Ethiopia, for Ethernet, a catch-all identity provider, and I hope to add the Ethiopian IDP in the list on the right side by the end of this Hackfest. Some of you proposed this, so we will be doing this. We will support you in doing this in the next couple of weeks, and at the end of the 2 weeks you will be able to see this, and Ethiopian researchers enrolled in your IDP will be able to access these services seamlessly. Dissemination and training, usual objectives: communicate the project, advertise the results, run workshops. This is the main communication interface. This is the website. Maybe you have already seen this. And we have several key pages. One is the Open Science Platform. This is, if you go to this page, this is a clickable map, so you can navigate on the map and get information on all the elements of the Open Science Platform. And yeah, you can click on this map. We also have the Dakar Declaration. We ran a workshop in Dakar almost 1 year ago, and we came up with a declaration to support open science in Africa. So if you share this, now we have this can be the number is outdated. We have almost 150 signatures, and you can go to this page and sign yourself if you support open science in Africa. We are trying to demonstrate to funding agencies how big is the support for this open science and open data in the continent. But we also have what we call institutional signatures. So the Open Science Declaration has been signed by representatives or legal representatives of several institutions. NRENs, several NRENs in Africa, universities, research organizations, and so on. We have the service catalog. So if you go there, we have the services that are offered to the community, to the different communities. So for the community, we have applications. We have the forum. For the computing, we have Africa and Arabia Rock. For data and documents, so we have knowledge bases, semantic search, open access repository, and so on, software, and so on. So if you go there, you can navigate and you can get information and download or access our services included in the catalog. We also have a page. How can we help you page? That one. According to who you are redirected to training material, documentation, and guides and guidelines to access or create your own services. We also have work package on training, and the Hackfest was actually the main output, the main outcome of this activity. This is the fourth Hackfest. We ran 2 Hackfest in Catania in July, in 2 consecutive editions. We had 36 participants from 9 countries, 4 African and 5 European, lots of instructors, 22 full days of intense work, more 10 hours of professional edited video, 20 hours of video streamed and recorded, 18 video interviews, and what's important from the scientific point of view, 13 use cases, 7 from Africa and 6 from Europe. We ran the 3rd Hackfest in Lagos, Nigeria, in the second half of November. 31 participants from Ethiopia, it was Bihailu and Yosef, Ghana, Italy, Nigeria, and South Africa, 9 instructors, and we got 13 use cases, all from Africa. 12 were new use cases, and 1 was just an extension of a use case already developed during the Summer Hackfest in Catania. Here we are doing exactly the same. So you sent us your applications, we evaluated them, we selected you for coming here, and then we will be supporting. We will record everything, and everything will be made available through the website and the open access repository, our YouTube channel, our course system for you to follow after and to reuse completely free. So here we are. This is the 4th. This is the Ethernet eResearch Hackfest. We are running here at the Ethernet premises from today till Friday 24th. The event is supported by the European Commission through the Ethernet participation in the Ubuntu Net Alliance, which is one of the partners of the SciGaia project. And the main objective is to integrate scientific use cases through a pervasive adoption of web technologies and standards and make them available to their end user through science gateways, or to develop services that are complementary to science gateways, like identity providers, open access repositories, and so on. But the real goal is to promote and foster open and reproducible research in these 2 weeks. So these are the topics that we will touch in the next 2 days. Distributed computing services, distributed storage services, programmatic access to open data repositories, semantic technologies, user interfaces, identity federations, open courseware. And these are the tools that we will be explaining you in the next 2 days. And you have links to all these things, but you will see in much more detail after this presentation. So how this will be done? You came with a use case, okay? We will expose you REST API. So you will interact with the services of the Open Science platform only using REST API, the language of the web. And through REST API, we will show you how to access services of tools. And these services are actually deployed on an e-infrastructure. So you will be able to connect to our services and exploit the services to implement your use cases. And you will be doing this using REST API. The only language that we will be showing you is RESTful API. How's the program? So in the first 2 days, we will present tools and technologies. You will get all the information about tools and technologies. Then the 3rd day, you are on the stage. I already sent you an email asking you to prepare 15 minutes presentation. I will send you the template you will be able to use, and each proponent of a use case should come here and tell us what you want to do. To describe, to present use case, but we expect that you also tell us which of the services you have been listening in the first 2 days you plan to use. So be ready to finalize your application tomorrow evening. But by today or tomorrow, I need from the presenters name, affiliation, and a short abstract, because I need to fill the agenda of Wednesday. So Wednesday, you will be on the stage. Okay? So you will be listening the first 2 days and telling us what you actually want to do in the third days. You already sent us some application description. We want you to elaborate on what you already sent us and tell us which one of the technologies and tools that we will be explaining you in the next 2 days you will be using. And then from the fourth day, we will support you. So people here, all the experts here, we will work with you next to your seats to help you implementing your use case. On Friday 24th, you will be on the stage again, because you will be asked to run final presentations. So you will make again a 15 minutes presentation, 20 minutes presentation, and tell us the final achievements you have got. Okay? Most probably next Saturday, you will be asked to also to make a short presentation, because we will be running what we call a checkpoint day, where we will be listening where you are at midterm, and if you have showstoppers and you have big problems. So you will be on stage 3 times: Wednesday, Saturday, last Friday. And you will be presenting what you will be doing and what you have done. So it's a really interactive. It's not a normal course. It's really a Hackfest. Okay. So, summary. SciGaia is very much committed to promote the uptake of open science, and we are building a federated platform of what we call Open Science Commons. You will see more in details in the next presentations. And Ethernet Hackfest, I told you, is we like this definition. It's a scientific, technological, but also social attempt to exploit web technologies to uptake the open science paradigm in a truly international and multicultural environment. So we will be really enjoying working with you, but we expect a great interaction, so that at the end you will be actually able to understand the services, use the services, and promote the services to the other communities. Thank you. Questions? Questions or comments? Before, I want to put again the agenda. So this is today, this is tomorrow, this is Wednesday. Presentation of use cases and their implementation strategies. So I need your names, the titles of your presentations, and your abstract to fill this agenda for Wednesday. Questions? Okay. No questions? So, okay, if there are no questions, now we are going to have the first of a few presentations, remote presentations. Is Bruce available? Yes. So, deve chiamare. Okay, so if Bruce is available, you should call me. Me. He has my... You should come. Okay. Hi, Bruce. Hi, Bruce.
Good morning, everybody.
Good morning, Bruce. Can you hear me? Digli che chiami anche te.
Good morning.
Digli che chiami anche te. Nella stessa... Just a moment.
There's a very, very, very long delay of about 5 seconds.
Gli hai detto di chiamare te? Bruce? Ok. Here is Bruce. Bruce? Deve fare il gruppo. Arriva? Lo posso aggiungere io te, eh? Ok. Chiami tutti e due? Ma se chiamava lui è meglio, perché per noi è download. Non so se è simmetrico qua. Metti in mute il tuo microfono. Metti in mute l'audio, non il microfono, l'audio. Ok. Bruce, can you hear me?
Yeah, I can hear you.
Okay.
I can hear a lot of feedback as well. So
Yes, now we are
okay.
Try to share your screen. Try to share your screen.
Right, well, I can't hear anything outside. I can just hear some sound, so I'm assuming you can all hear me. Excellent. All right, Mario, if I need to stop, please just tell me to stop. And when I need to change the slides, I will let you know. Sorry, when you need to change the slides, I'll let you know. So good morning, everybody. It's a great pleasure to be speaking to you, even though from afar. I'm going to be speaking about things which we've learned during the long experience of running not just this kind of Hackfest, but the development of e-science applications in general. As you probably know, Roberto and his team have a very long experience with this, several years in fact, and I have been trying to provide infrastructure for these applications for just about as long in Africa. So there's a couple of suggestions or guidelines which we've discovered along the way, along with best practices from the rest of the world, and by that I mean the kind of work that's been done on web applications, that we'd like you to keep in mind. So let's dive into it. First slide. the question that we all come in our minds when we start this event is basically, what are we even doing here? Most of you have a pretty good idea of what you want to build, but you may not have a very good idea of where that application or that service is actually going to be running in production, and how people are going to be using it and so on. So you have a good idea, but you're not really sure about the endpoints. Next slide, please. So we need to keep some things in mind. First of all, we live in a very big, wild place. The web, just like Africa, is big and wild. There's many, many freedoms. You think you have the freedom to do many things, but in fact, sometimes those freedoms work against you in the sense that it's difficult to collaborate or have your things run on many places. It's also evolving very rapidly. I'm sure most of you can remember a time when there was very little or no internet access, when most of the software that you had to use cost a lot of money and so on, and there wasn't much choice for deploying, even writing applications. And now we can do this quite easily. So you need to have a very good awareness of what's going on around you, and that will help you to make some good choices, or at least avoid certain bad choices. So while you go through these 2 weeks in developing your applications and your services, we are also trying to improve this actual event. As Roberto said, this is the third time we're running it, and every time we run it, we try to learn from you the ways which we do things, the ways in which you would like to do things, and so on. Thinking about existing patterns, which we will go through in this presentation, but we want you to actively think about what you're doing so that you can help us to identify new patterns, especially in the way in which we run this course. Next slide, please. Okay, so Roberto showed you his screenshots or the web page for what we call a platform for open science. I was following just now the live stream, so I know you guys have been told about this. You know that it's a clickable map, etc. What we want you to keep in mind is that this is not the platform. There's many, many projects out there which are calling themselves the various combinations of platform, open, and science, and they're all very different things. I think what makes our interpretation different is that all of the components which you see here are generic, so they can be installed with various different kinds of services offering the same functionality. So you can have different kinds of fora, you can have different kinds of e-learning systems, different kinds of computing platforms, but the important thing is that they interact with each other, as Roberto said, via these REST APIs. Why via REST APIs and not other way? Well, that's just because it's a very complex place, and the way in which you get lots of different components together on the web is via REST APIs. Next slide, please. So here's the outline of the presentation. Why are we going to talk about patterns? There's a good reason that we're talking about patterns and web application hosting services like Heroku, about what makes a good web application. We've seen the rise of cloud computing. We've seen applications being called cloud native. And we want you to keep in mind that this is the direction in which things are going, and the various aspects of an application which make it cloud native. This is the so-called 12-factor application, which I'll go into. And then not necessarily a practice, but a pattern of continuous integration. This is a method of writing and testing code such that it's always ready to be used. It's one thing to develop your application, but we are also developing the place where the application will run. So we're going to be speaking about what you can expect from infrastructure to be able to host your application, and the scientific applications that it may need to execute. And here I'll go into the various patterns of how e-science infrastructure works. Then there's a few patterns in research which we would like you to keep in mind. Basically, we're going to explain a little bit what we mean by open science, and particularly as it pertains to data. The last one that we'll speak about are integration patterns, and these are the ways in which you bring your components of the open science platform together to offer a service to the community. Next slide, please. I just want to stop here and ask if everybody's okay. You can hear me fine, the slides are okay. let's see. Okay, everything's fine. Great. Just that I can't hear anything on that side, so I want to be sure. Okay, so why do we talk about patterns? I've got 2 quotes here, which come from a very good reference website called sourcemaking.com, and there they speak about 2 things. First of all, design patterns and design anti-patterns. Now, remember, we're speaking about design, not implementation, and so these are aspects of whatever you're building which cut across whatever it is you're building. In software engineering, a design pattern can be a general, repeatable solution to a commonly occurring problem. Okay, so that's not a finished design which you can transform directly into code. You mustn't think of it as a template. You must think of it as a way in which you can attack certain problems. Okay, that's all good and well, and if you read through those design patterns, most of them will probably make intuitive sense to you. But I think the more important one to read are those of anti-patterns. So these are habits which we find ourselves falling into to solve commonly occurring problems, which actually make the problem worse or make it bigger problems later down the line. And in fact, these anti-patterns are probably the starting point for most of the thinking that you need to do before you start actually writing your applications. Okay, so I've got these 2 references in here. I'm just going to leave them as references, and in your own time you can see what they're all about. So remember, there's no right way to work on these projects. All we asked for you to come to this meeting was that you knew the language of your choice and that you understood basically how you wanted to do it. We don't make any specification that the language needs to be any specific one, or the topology of the application needs to be any specific one. You have total freedom about how to develop these applications. And so we try to identify patterns by which good applications are identified. Right? Okay, next slide, please. We should be on slide, let's see here, 8. It starts with in the old days. Okay, so in the old days, and by the old days I mean about 5-10 years ago, not that old, basically the situation was as follows. If you wanted to do cutting-edge research in a digital infrastructure, you basically have to deal with the command line. Almost all of the high-performance computing or distributed computing infrastructures that were offered only offered access via command line. And so research workflows tended to be scripted. If you had to do things on the command line, you wrote a couple of scripts which could be executed on the command line. And those generated out of them an experience about a set of good practices, basically how to run workflows on the command line. Eventually, middleware stacks tried to make it easier to access distributed computing, so various aspects of the command line had to change. But still, the research was typically done in scripts. Okay, so we've got this habit of implementing our research workflows in things like Bash or Perl or maybe Python further down the line. Very few application stacks actually were there. So you can think about the classic ones of root or building things in Python, MATLAB and Octave. These are still things which tend to be executed on the command line. So the language of research was pretty much static, in the sense that you would write your workflow and it would execute once on the command line and then you would start over again. And the web was also like that. The web was also pretty much static HTML, and the browser was basically like your client, like the command line. You would look at one page at a time and then maybe make individual changes to them. There was no dynamic exchange of data. And so it's good, we've got a lot of work done like that, but it's not great for scientific work, especially when it comes to interactivity. Next slide, please. So what we've seen, especially with the increase in bandwidth, is that the features of our browsers have become extremely rich, in some cases replacing the entire functionality of a desktop. So you can run almost everything that you need to do work right in your browser. That's the only application you need. The web is not just for reading anymore, but it's for creating. It's a very creative tool, and especially for collaborating. Most of the features of the command line have now been replicated on the web. If you think about running DNA sequencing, you would need to download a special application, compile it, and then execute that on the command line. Well, now you can upload your DNA sequence to a web service and get the results right back. So the web, more than the command line, has tended to become one of the most important tools for scientific discovery. You have all of the functionality of the command line. Most of the applications which we executed on the command line are now executable via web interfaces, but we have all of the other things that the web provides as well. But we still need certain things to manage our workloads, to execute and to store our data. And so we still need access to platforms for computing. These are our high-performance computing centers, our distributed computing centers, and we need a specific application stack for our scientific work. Next slide, please. So you may think to yourself, well, great, I've got this new tool. It's the web. It's awesome. I'm going to build a web app so that people can use my service or my application easily via the web, and they don't have to have special access to things that you see in the last layer, the knowledge base, the open access repository, the science gateway, and so on. These live on the web. And particularly in the Science Gateway, these host the applications which we execute further down the layer of the open science platform in the Commons. So in the Commons, you don't explicitly use web technologies. We don't say that these have to live on the web or be part of the web, but they have one thing in common, and that is a set of open standards, which makes the web what it is. You know that you can basically interact with any web page via a browser. And so that's interactivity, that interoperability is what makes the web such a good place. So the first pattern we see here is that of interoperability. We need our services and our applications to easily interact via standard language or stack with the various components of the science of the open science platform. Next slide, please. Okay, so you may think, okay, I can do that, no problem. Which standards to adhere to? That's the problem. Interoperability is good. I just need to know. But the problem is that there are many, many, many of these, and there's no real way to tell you what to do, because the web is a pretty wild place. There's just freedom to do anything you want, which that's also the reason why it took off so well. So we need to think a little bit about how this web application is going to live and evolve, right? It's one thing to write a PHP code on your laptop and say, okay, well, I can just deploy this to a web server, but then is that web server going to scale? Is the application doing the right thing? What happens if that web server goes down? All of the problems associated with not just scale, but also evolution need to be thought about. Your application will run on some infrastructure, and what we're trying to do with these Hackfests is to motivate research providers, so NRENs, to provide these infrastructures. And here I'm referring to basically cloud installations or computing platforms. Okay, so we're going to go into a couple of patterns of what these applications should look like, such that it makes it easier for them to live on various infrastructures. Next slide, please. Okay, so we're going to start with patterns in applications. Next slide. Slide that starts with 12-factor applications. Okay, I'm just going to stop here and check with Mario, whoever's following me, that we're on the same page and everyone is okay. Yes, we are. Excellent. Thank you very much. Okay, so 12-factor applications. You may have, or may not have heard this term before. It's a relatively new one. This comes out of basically a few years of experience actually running applications. It comes from a company called Heroku, which is one of the biggest web application hosters. And these are aspects or factors of an application which makes it more likely to be easier to deploy on different kinds of infrastructures. So we're going to go through them. And I want you may not remember all of them, but you need to remember the website, 12factor.net, so that you can ask yourself whether the way in which you're developing your application respects these. Bear in mind that not all of these factors will be applicable to your application. Some of them may not make sense, but these are good practice suggestions. Right, so let's go through them. The first factor is to use clean contract. Means that, oh, we lost me. Okay, I'm going to stop here. Okay, great. So let's have a clean contract. A clean contract means that there is a very clear intention and the service which hosts it. So you don't have any explicit declaration of where to run the application, hard-coded paths in the application configuration, specific hard-coded variables such as the port or the URL. That means that you can have the same contract. That means trying to execute this application on various different places, which may have different internal configurations. Okay, a 12-factor application is also suitable for deployment on what's called modern cloud platforms. So that means that you shouldn't require the need for a server yourself. You can have one, you can host this yourself, but you shouldn't require that. Then a 12-factor application minimizes the divergence between development and production. So this is actually a very important aspect for the next 2 weeks. The way in which you develop your application in the development environment should be as close as possible to the way in which it will actually run in the deployment environment. So you may not even know what the deployment environment is, so you need to simulate that. And so we've gone to a little bit of length to provide you with such a simulated environment, which we will tell you about as the days go by. Okay, the last one on this page may not be all that relevant, and that is that applications should be able to scale up without significant changes to tooling. So if you're using a database, that database should be replicable. If you're using a web server, you should be able to provide that web server in a high availability configuration, etc. All right, next slide. Slide that starts with code base. Okay, so code base, this is basically where you will be putting your hands on the keyboard. The suggestions for a good 12-factor application is that the code base should be tracked in revision control, and you should be able to deploy many deploys from one revision control, one service. Okay, so don't keep too many branches in there, and make sure that there's a well-known central place where the deploys happen from. This may not be intuitive to you, but you should get into the habit of making sure that if your code is not in the revision control, basically it doesn't exist. Okay, so the cycle of editing, testing, committing, and pushing should become second nature to you. Okay, next slide, please. This just shows a picture of what we mean by having several deploys from a specific code base. The code base should be instantiable using different variables for different environments. So you've got the first developer's environments, the second developer's environments. These are maybe two people in a team which are working on the same application, and they use the same code base, although they may have slightly different testing environments. When they try to pull things into the production environments where the application will actually live, then you have a staging environment where these two things are tested. And if tests pass, the same code base gets pushed into production. Okay, so try to avoid two people working on the same application in two different repositories. Okay, next slide, the one that starts with two dependencies. Okay, so a good 12-factor application explicitly states what dependencies it has. Most of you will be writing applications in Python, PHP, or Ruby, Ruby on Rails, that is. Maybe you have some Microsoft-based stack like ASP or .NET or something, but all of these have their own package management systems. So these dependencies should not implicitly rely on something that's available on the system, because you don't know where this application will be running. So you should have some declarative way to tell the system which dependencies your application has. Okay, you should also use a dependency isolation tool, whatever that is, for your language stack, so that you don't leak in system dependencies. In other words, the application shouldn't by accident use something that's on the system that it should bundle together with itself. And the reasons for this are many. You probably bringing in some insecure or untested version of that dependency and so on. Okay, the other thing is that you can't really test how your application is going to act in a production environment if you don't know that it's using only the dependencies that you explicitly state. Okay, so this is another thing that we're not used to in developing these applications. You need to explicitly describe the dependencies in a declarative. Just checking if you guys can hear me. Yes. Got you back again. So configuration, we often tend to store configuration in a configuration file. There's a couple of very bad reasons for that. So the suggestion for a 12-factor application is to store the configuration in the environment. I won't go into the rest of the slide. Basically, that means that you can deploy the application with a different configuration by expressing variables in an environment. Okay, that means you can easily change the environments. This comes back to using similar environments between development and deployment and so on. Okay, next slide, backing services. Number 4, backing services. So backing services are things like the attached storage which you're using, maybe the web service, sorry, the web server which you're using to expose this web application. Perhaps you have a messaging system or a caching system, anything that the application itself doesn't do but is necessary for the application to run. Okay, again, you will be deploying this application to a place where you don't have full control over the backing services. So the backing services should be treated as attached resources, something that you can just plug into. And this comes back to the thing about having a clean contract with the infrastructure provider. If you express everything that you need in the application, you will also be expressing your need for a database. And if the infrastructure provider can't provide you with that, then you know that you can't run your application there. Okay. So basically treat backing services as attached resources. Next slide, number 5, build, release, and run. Right, so this is the evolution of the application. And the suggestion for a 12-factor application is to use strict separation between these environments. The build environment, the release environment, and the run environment. Into these 3. Here is where that single code base is transformed via the setting of various variables. That's why it's important to separate them. You don't keep the configuration in a file, but in something that can be instantiated at execution time. Okay, so build, release, and run, something that you will be dealing with later on in the Hackfest, not necessarily in the first 3 days, but bear in mind that for you to do this properly, those 3 environments will be strictly separated. Okay, next slide shows you pictorially how we separate these environments. Basically, you can see that the configuration, which is in an environment, is pulled in at the time that the application is built to be able to run the application. Okay, it's not kept together with the code base. Right. Next slide, slide 22, which starts with 10 dev prod parity. So dev prod parity is something that basically wastes a lot of time of people who are actually hosting this application in debugging. Often we get a request that says, my application works when I tested it, but now when it's running on your side, it doesn't work, don't know what the problem is. And this comes down to the fact that most of the time there's a difference between the development environments and the production environments. So a good 12-factor application should keep those 2 environments exactly the same, barring certain variables. Okay, so what we suggest here is to keep the development, staging, and production environments as similar as possible. Now, you don't have control over the production environments because you don't own that, but you can simulate it. And that's what we have provided for you in the beginning of this course, is a simulated environment which looks just like the place where, or as close as possible to the place where your application will actually be running. Okay, the URLs or the names of the backing services may change, but the environment itself is exactly the same. And this is designed to keep down 3 gaps. These are gaps which basically extend the amount of effort that it takes to run or maintain the application. The first one is the time gap. So the developer may work on this code that takes a lot of time, put all their effort into it, and then when it comes to production time, there's more time necessary to debug the application if the dev prod parity is not maintained. The second one is the personnel gap. So if you think about the differences between various people in this, you have developers, operations engineers, and maybe some security engineers. If you're working in different environments, then those 3 people have to do all different kinds of work. If you have the same environment as a reference, then you don't have to even have an operation engineer because the site will just keep running perfectly. The third gap here is the tools gap. So in your development environments, you may be using one stack, and the production environment, which is some cloud provider, may be using or exposing a different stack. And so you need to do more work as a developer to change your application to use that. This comes back to the clean contract and dependencies that we mentioned before, the other 2 factors. So we've gone to a lot of trouble to ask you to express what your stack is. And we've also gone to a lot of trouble to simulate the production environment where your application will run, such that you can test the application in a development environment in the same way as it will run in a production environment. Okay, let's move on to the next bit of the presentation. That's all that we have to say about the 12-factor applications. I've just highlighted the 10 most important ones. There are 2 others which I don't think are that relevant for this. But we're going to move on now to a practice called continuous integration. Continuous integration, there's basically not a well universally defined definition for it, but basically this came out of many different groups kind of evolving towards the same practice. You can read a very good definition or one of the good definitions at ThoughtWorks in the link that I provide on that slide. So continuous integration is a development practice that requires development to integrate code into a shared repository several times a day. Each check-in is verified by an automated build, allowing the teams to detect problems early. By integrating regularly, you can detect errors quickly and locate them more easily. So, did you guys want to say something? Okay, sorry about that, just got a bit of feedback. Okay, so this requires a service to do all these things for you. First of all, you have to check in the code because you're developing the code. But bear in mind this important verb here, the automated build, right? This is extremely important. This is not something that should be done by hand. This is kind of a code referee which automatically checks everything that you do to see if there are problems. This is particularly important if you're collaborating with someone. You may have conflicts in the code or so on. But we have again here provided a service for you to check these things. Now it's up to you as a developer to express what needs to be checked. Again, many language stacks provide built-in testing services. Ruby has RSpec, Python has nose, these kinds of things. You need to build these into your application along with the code. Okay. So continuous integration, if you are continuously integrating your code, there's more chance that it's going to be more robust and easier to deploy than if you're just hacking on it and you're not really sure what the state of the code is. Okay, next slide. This describes the practices of continuous integration. It starts with CI practices. So again, we're just going to run through these quickly. You don't have to do all of them, but the more of them that you do, you know that the more robust your application is going to be. So first of all, maintain a single source repository. Don't keep code left lying around in various places. If you do that for architectural reasons, make sure that the various repositories are added to a single one as submodules. Automate the build. Make sure that the build is automatable. So you need to express the way in which this application needs to be built in some kind of script. Make your build self-testing. So Don't rely on a user interface tester as a human being to go around and poke buttons on a web page. You can express these things automatically, and there are frameworks to be able to do that. Each commit should be built on an integration machine, and the integration machine should be exactly the same as the production environment. This is building into the next two ones, that is keeping the build fast and testing the code in a clone of the production environment. So you don't push your code directly to the production machine, you keep it exactly the same as the production machine, and if the build passes, you get a deployment happening. Make it easy for anyone to get the latest executable. So that means basically tagging your code and releasing your code, or keeping your code in an explicit branch that makes it easy to understand which one is the right one. Make sure that everybody can see what's happening. This means that the testers, the users, the application hoster, all of the people that are involved in actually providing this application, they should have access to the source code and access to the results of the build. And lastly, of course, try to automate the deployments just as you automate the integration. Okay, next slide, slide 25. We are moving now onto, so we've moved out of patterns of development of applications, and we're moving into patterns of execution, okay? How these applications, once built, tend to be deployed and executed out there in the wild. Right, so next slide, slide 26, that starts with grid computing patterns. Now, I'm not sure how many of you are building what's called kind of batch or high throughput applications. These are applications which may have different kinds of interfaces, but when they execute, they run on high platforms. These are kind of back-end applications. In any case, I'm going to go through the various patterns that we see in them. So, grid computing patterns are basically, there's a few of them, and I put in here a reference for the different kinds of patterns that we see in distributed computing. To quote, whereas a consensus has been reached on defining the set of workflow patterns for business processes, no such patterns exist for workflows applied to scientific computing. And that is because there's so many different things that need to be done in a research workflow. Usage patterns have emerged rather through the reuse of community tools. So the patterns that we see when using distributed computing platforms are more driven by the platform itself rather than the need of the research community. Right, so this comes down to a certain middleware providing you with a certain functionality, and so you tend to use that functionality to execute your workflow instead of the other way around. And that's just a historical artifact of the way these things were built. So for a full list of these workflow patterns, I put in a reference at the bottom there. It's a pretty old one, and I'm still looking around for a good review article of a newer one, but it's pretty good. So you can read all of them in there. Next slide, please. When we talk about grid workflow patterns, these are kind of fire and forget, batch, whatever you want to call it. There's basically two kinds of execution models. You should take this into account when building the user interface of your application, because you need to know that these kinds of executions will happen, and build your workflow in the user interface around them. Basically, there's parallel execution and pipelined execution. Obviously, this explains very well what it is. The parallel one means that many tasks are executed at the same time, and the pipelined one means that there's a sequence to which the tasks need to be executed. Of course, there's difference between compute parallelism and data parallelism that comes down to basically the distribution of these tasks according to where the data is or according to where the CPU cores are. And there's no obvious way to do this. It really depends on from application to application. Next slide, slide 28. So if you have a parallel application, let's say you're running DNA sequencing, or you're running the simulation of a weather model across various grids, or anything like that, that you can split up into individual tasks, then you have what we call grid parallelism. If your application is compute bound, then the workflows are quite simple, and they can be easily partitioned depending on the nature of and the dependencies between these tasks. So you may have a very simple combination between pipelined and parallel execution. Again, I'm mentioning all of this because it comes into effect when you design the user interface. You can easily set up an execution of a grid parallel application with a very simple user interface. If you have something that requires more interface data activity, then you need to work on a different user instance. These can be defined as static data parallelism, so the data set doesn't change. Dynamic data parallelism, so the set of tasks changes according to changes in the data. And adaptive data parallelism, where both of these change at the same time. Okay, so you may not recognize which of these patterns your application fits into, but these are the patterns that they could possibly fit into. So you should start to think about, okay, well, what is my application doing now? Next slide talks about pipeline execution. All right, these are different kinds of parallel computing patterns with pipeline execution. Again, these are kind of industry terms, stuff that you will read in academic papers. I'm leaving you a link at the bottom of this slide to describe all of the various kinds of tools which can be used to construct pipelines. That repository is just a list of tools which are used to construct pipelines on various platforms. So it's left there as a reference. Okay, I'm going to move on to slide 30. We're done discussing grid computing. Okay, I'm stopping. No problem. Okay, so you need me to halt. All right, sure.
Sì, ma così lo vediamo. Digli che manda che apre la telecamera. Così lo vediamo, lo riprendiamo. Quando c'è il welcome. When is are coming? Okay. So we need to go downstairs or we need Okay, here. Okay. There is the break, okay. So di Abruzzo che c'è il break 10 minuti. Ok. 10 minutes.
10:30?
Yeah.
Or we'll start as well.
Okay.
The lunch is 12:30.
Okay, then we need to change the agenda accordingly. Okay. So we are breaking for 10 minutes. Okay. Inquadra questo. Noi stiamo sempre streamando, giusto? Sì. Ok.
Hey guys, I take it you're all back. I'm looking at my slides. Excellent. Okay. Right. Just give me a second to get on the right page again. I can't hear myself, so I'm assuming you've muted me. Ah, okay. Okay. Sorry, the delay I was referring to before was actually the live stream that I was watching. So, sorry about that. Okay, slide 29, on to slide 30. Where we left off, we were talking about grid computing patterns and the way in which applications tend to be executed on them. We're going to be speaking a bit about now the cloud usage patterns. And this is very, very, very deep waters. This is something that you can run an entire conference on, let alone one specific presentation. But there is some stability here that I'd like to just have us refer to. So the reference that I'm using here is something, a website called Cloud Computing Patterns. It's exactly the same as the title of the slide. This tries to have a taxonomy of ways in which we can use a cloud service to run science. Okay, so which kind of cloud workloads do we have? Basically, we can have a static workload where there's a service which stays up and provides a continuous similar functionality. You can have periodic workload, which is somewhat more elastic than the static workload. It's only available when people want it. Then you can have once in a lifetime workload where some configuration is constructed on the fly and then is executed and destroyed, never to be run again. You can have unpredictable workload in the sense that you have a service which can construct for you the orchestration of the services that you need, but you don't know what they are a priori. People can choose from a set of configurations, etc. And you can have something that's continuously changing. So you can kind of predict what the workload is going to be, but it's changing over time. So whereas grids and high performance computers, they work very well under static or periodic or even once-off workloads. You can think about HPC in this sense. Clouds are typically designed to deal with many different kinds of widely varying workloads. And so they are functionally a bit different to the ones we've seen before. Next slide, on slide 31. We're going to speak a bit about research patterns now as we go towards the end of the presentation. Okay, slide 32. The first pattern that we want to recognize is pretty obvious. If you've come into this event, then you basically have an idea of what open science is. And you may have heard in Roberto's presentation about the fact that it's not necessarily a thing, it's a way of doing things. So it's a means, not an end. It's not, you don't do something to make it open science. You open your science so that you can do other things. And what are those things? These are things like to be able to reproduce your results, to be able to have others openly review and so improve the quality of your results, to be able to publish your results in a way that is accessible to as many people as possible, etc. That is what open science is. It's a pattern of doing science or conducting the things that we do in normal scientific day-to-day life. Not just the execution of the research, but also everything that comes after that, like review and literature. So to be able to reproduce and validate research, we need our platforms to be able to do that too. We need things that are reproducible, that are accessible, etc. And so we bear in mind here that actually at the end of the day, the data of our research is the key. This is the product, the result of what we do in our open science day-to-day lives. Right, so slide 33 tries to zoom in on what we consider the important aspects of data in an open science paradigm. We refer to a term called FAIR data. FAIR is an acronym standing for findable, accessible, interoperable, and reusable. Here it's used for data, but this can be applied to other aspects of our open science platform, in particular the execution and data infrastructures. These also need to be findable, accessible, interoperable, and reusable. And there's a set of principles which guide how to make your data fair. And these are maintained by the so-called Force 11 group. That's the future of research infrastructures. Force 11, I've given the link there so you can see all of these principles in detail. Okay, so I'll leave you to read through those principles in your own time, but basically remember that if you are building an application which consumes or produces data, then you need to make it accessible, interoperable. You can't choose whatever format you like, reusable. So it must be somewhat semantically enriched. You need to understand how to use this data. And there's a set of principles which guide you to be able to make this data fair. Okay, next slide, slide 34. What does it mean to be findable? So findable means that you must have your metadata associated with a globally unique and persistent identifier. Okay, essentially just the metadata, because the metadata will allow you to discover the data itself. But if the data is assigned a globally unique and eternally persistent identifier, that's also a good thing. The data should be described, obviously, with this metadata as far as possible, and the metadata should be registered or indexed in a searchable resource. Now, we're mostly comfortable with the fact that Google is indexing and presenting all of our day-to-day life, the stuff that we put on the web. And so we need to do that as well for our data. If we just put data on the web, it's not automatically registered and indexed in a place where people can find it. Okay, to be accessible. What does it mean to be accessible? The metadata must be retrievable by the identifier, not with some explicitly hard-coded URL or URI. So they must be, first of all, findable in the first point, and the metadata must be retrievable using standard communications. So no special username and access protocol and so on. Basically, you should be able to find the metadata and retrieve it over the web. The protocol should be open, free, and universally implementable. That means that if you want to write an application which consumes this data, you shouldn't need to pay for a particular license for a protocol or codec or something. That harkens back to openness and accessibility. The protocol should allow for authentication and authorization where necessary, so not by default. The metadata should be accessible even when the data are no longer available. So you should be able to describe this data, and then even if the data are removed for their size or date or so on, you should still be able to index that metadata. That's why we mean there should be an eternally persistent identifier of the data. So you can still refer to it. Next slide, 35. In order to be interoperable, the metadata needs to use a formal, accessible, and broadly applicable language for knowledge representation. So that's a bit of a mouthful, but what it means is that you need to enrich the data with a human understandable and a machine understandable way of describing it. This can be XML, it can be JSON, it can be some specific community description, but it must be formal and accessible in the sense that it can be easily translated into various formats. The data should use vocabularies that follow FAIR principles. So if you use a vocabulary that does not make things accessible or findable, then it's no good. The metadata should include qualified references to other metadata as well. That's a fairly technical one, but it just means that you can link various datasets. Lastly, to be reusable, that's the R in FAIR, the metadata have to have a plurality of accurate and relevant attributes. They must describe things like the date of creation, who owns them, how long it's supposed to live for, things like that. These are attributes of the metadata. The metadata are released with a clear and accessible license. This applies as well to the applications that we're using, but releasing data without a license into the wild means that it's essentially unusable, because you don't know if you're going to get into trouble for publishing reanalyses of that data. So whatever that license is, if it's an open or closed license, should be attached to the data in the metadata. The data should be associated with their provenance, which generated these data, which research provided this data, how it was published, and so on. Otherwise, again, you have no idea whether or not you can trust or use this data. And then the metadata or the data itself should meet domain-relevant community standards. That means certain aspects of peer review, certain aspects of publishing workflow, and so on. These are all defined by the community itself, and there's no catch-all definition for them, but that makes your data trustworthy, reusable, understandable to people coming down the line. Okay, next slide is slide 36. And here we're coming back now to take a closer look at our open science platform. The platform of components and infrastructure which allows us to develop web applications which implement an open science workflow. On slide 37, we're going to zoom into infrastructure services. That is the bit in the commons with the black box around it, which is usually hidden away from the people developing applications, but which we critically depend on to be able to run large workflows. So we need infrastructure services for our users. We need to authenticate and authorize them, and we need to manage their identity across the various underlying services like workload and compute management or data movement and storage and so on. Often what people do is try to implement all of these aspects natively in their application. So either you may have a username and password in your application that blocks the integration of your application with services down the line in the platform because you don't have an easy way to interoperate with them. And that is why we rely so much on federated identity management, the ability to translate a user's context from the web application to the compute infrastructure and the data infrastructure, as well as other things. Right, so there's many, many other services in the commons, which we refer to there. And the urge here, as I said earlier, is for you to implement most of these things easily in your application. And we want you to avoid that urge to take advantage of the other services in the platform later down the line. So you will feel some pain in the beginning, but that will give you a big payoff later. Next slide, on slide 38. Where can you get all these services? So if you take a look at that open science platform, we've tried to be as comprehensive as possible and whatever could be used to build a web application. But remember that there's no single infrastructure, whether that is one that you know about or one that's coming down the line, that will do everything that you want. This is just the nature of public infrastructure. You need to access lots of different things to do what you want and maintain the freedom of your application that you desire. Otherwise, you get stuck into that situation you had before where the middleware or the platform defines what you can do. We want to break that pattern. We want to say, okay, you're free to do what you can do, but to do that, you need to use lots of different infrastructures and services. The way you can do that without suffering too much is by adopting these open standards and by building 12-factor applications. By doing the first, you know that you can more easily access services from different platforms or different services. By doing the second, you know that when things change, when your application evolves, or if the infrastructure itself evolves, you can still offer this application and you don't have to rebuild it from scratch. And that allows you to develop more easily what we call these open science applications. And most of all, I think the most important suggestion that we can give here is not to try to implement everything yourself. You may design your application and think, okay, I need this and this and this, but before you go and do that yourself, take a look around and see which services are available via a platform. And then plug your application into those via the REST APIs that those services offer. Next slide, EGI. So what can you actually plug into? If you take a look at the European Grid Initiative service catalog, you can see that there's a couple of services which you can use and the description of how to use them. Services which provide compute functionality, that may be high throughput computing, as in grid computing, or cloud container compute. These are generic endpoints which you can send your workflows to, as long as you write your application in the right way. Same goes for storage. On the next slide, we see services that you can use more close to home. Roberto mentioned the availability of these services in the Africa-Arabia Regional Operations Center, and you can read about that more at africagrid.org. We obviously encourage everybody in the room to consider using these, but also to join the platform to provide resources to it in order to better support the community. This is a peer of the EGI, so it's basically the same functionality provided via local resource providers with a little bit of tweaks here and there. Okay, so again, these are not a unified infrastructure. This is not one thing that you can plug your application into. This is a federation of services, and it defines what we call an open infrastructure. That means that if you want to bring your own service, you can do so, and you don't have to do things according to a vertically integrated way, but a more horizontally integrated way. Okay, next slide, slide 41. We've spoken a lot about the various patterns that we see in applications. We've spoken about the fact that there are 12 aspects of a good portable application on the web. We've spoken about the way of developing these applications to make it better maintainable in the future, and about how you can expect to execute these applications and integrate with various services out there in terms of the various platforms that we have, grid, cloud, whatever. Let's talk about practically getting this experience into our code base. So the most important thing to remember are these two things. Develop your application as if it were running on something that you have no control over. And that makes it a good 12-factor application. Remember not to give in to the temptation to develop things yourself in your own particular, easily understandable way, but in a way that respects the open standards of platforms. These platforms will make it easier to consume and provide REST APIs. So that means that you can pull in functionality where you need it. We will go into the details in the next presentation about how to do that for the various platforms like the compute and the data. But just because we want to support standards-based access to infrastructure doesn't mean that this infrastructure is going to be magically available. That means that you need to estimate how much people are going to be using your application, and you need to estimate what kind of load that is going to put on where this thing is going to run. That may be quite hard to do initially while you're developing, but keep that in mind. This is not something that's going to just magically work out there. You need to have some kind of contract with whoever it is, financially or otherwise based, to be able to execute this application in the wild. And that comes down to integration. So the next slide talks a little bit about integration patterns. I'm on slide 42 now. Okay, so integration patterns come down to three things to remember. First one is that everything is code. If you can't express what you're doing in some kind of code that is in a file that can be compiled and executed in some way, then you're doing something wrong. If you need to provide manual steps to doing any particular thing, and if those become more than the automatable things, then you're doing something wrong. Only you will know what you're doing wrong, but when you find yourself, let's say, clicking buttons instead of typing, then something is not right. So if everything in your application can be expressed as code, then you're doing good. And you're reducing your reliance on so-called magic wands, things that only you know how to do and which only you know when to do. And that is, by its definition, a manual intervention and something that you need to reduce, because who wants to be doing these things manually anyway? That ties into the next point about automating everything. So again, if you can express something as code, then you can execute it. And if you can execute it, then you should automatically execute it. So the more places that your application can run, the better chance of people actually using it, which is a good thing. You should make the deployment and the configuration automatic, in the sense that whoever wants to actually provide this application can do so with a minimum amount of effort. If you look at any widely used application out there, whether it's something that's running via an installation package or just downloading things from the web, consider the Chrome store, for example. If you want to put an application in your browser, there's so little effort involved in installing those applications that they make it very easy to use. You should aim for that. There's a heavy reliance on automation. The last point is to make things robust, and that is, it shouldn't work only if you do certain things. It should work even if you don't do certain things, or even if you don't do anything. There's no magic way to do that. There's no easy way to say I am doing it or I'm not. But here are some considerations. First one is to reduce the number of so-called moving parts. That is the number of independent aspects of the application. This comes back to the insistence of having a single code base, for example. But if your application depends on lots and lots of different things all getting just right, then you should take a moment to reconsider. Identify and reduce the single points of failure. There are inevitably going to be single points of failure, but and not all of these can be or should be removed. For example, the authentication mechanism may be a single point of failure, the storage may be a single point of failure, etc., etc. Maybe even the network that you're running on may be a single point of failure, and you don't have full control over them, but at least identify them and try to reduce them in the design as far as possible. Lastly, just remember that you need to test everything. And these tests, as we said before in the continuous integration part of the presentation, should be automated. Not all of them will be able to be passed automatically, so some of them you have to do manually. You won't be able to test absolutely everything, depending on how you're building your application, but aim for that 100% test coverage. And then you know at least how your application behaves in certain environments. Right. Slide 43. Integration patterns still. So use the infrastructure as backing services. We've gone to great lengths to emphasize the fact that you should use backing services and infrastructures in a way that's independent of your application. So try to offload the compute or data-heavy services onto these platforms which we've spoken about, the grid computing platform, the cloud computing platform, and use the open standards adapters to do that. Don't write native integrations. Consider the data parallelism of your research. That means that send your workload to places where the data is and not vice versa. Only move data when necessary because data is heavy. To move it over the network costs time. Don't, or as far as possible, try not to implement your own identification and authentication mechanism, but use identity federations as far as possible. It's very tempting initially to just use some kind of OAuth plugin, delegate that to a GitHub provider or a Google provider or whoever you want to authenticate your people. But remember that you're going to need to translate that identity to different kinds of things using various services on the platform. So it's much better to use identity federations for the long term. Focus on the workflow. Don't try to get the user stuck into what you want them to do, but make sure that they can do the things that they naturally want to do. Identify which kinds of patterns users will, or your application will be using. That's why we went into the trouble of defining them. Write the web application to guide the users in these workflows. So not entirely open, but trying to explain to them what they could possibly do. And most of all, automate the things that you know that they have to do, and don't make the users do unnecessary tasks on the web application. You need them to spend as little time as possible pushing buttons and as most time as possible actually getting work done. Right, that is the last slide in this presentation, and I'm going to leave the floor open to whatever discussion we need to have or questions and so on. I'm going to turn on my video if I can.
Any questions to Bruce? Okay. I mean, this is very important. I mean, this kind of introductory talk will be more important when we will see the actual services. So, if there are no more questions, if there are no questions to Bruce, Rita, can thank Bruce again, and we can stop. Tell him to say the last word. Okay. Okay. Then let me check the agenda now. And we are here. So now Oh, sorry. Bru? Okay. So let me check the agenda. So now we are going to touch an important part of the Hackfest, which is the framework to build science gateways, to build portals. So also this presentation will be done remotely. So I'll see if Ricardo is online. Can you tell Ricardo to call me and you? Okay. Is he online? Disappeared? Let's wait a little bit. Let's see if it is online. I don't see him online. But you are in contact with him? Sei in contatto? Ce l'avete su WhatsApp? Ok. Ce l'hai? Io sì, tu dovresti rispondere. Recent, sorry. Ah, ok. Hi Riccardo.
Devi mettere muto quello di Roberto.
Ok.
Quello suo.
Ok. Dico di scerare le slide.
Io ho problemi su queste cose. Conversazioni. C'è molto eco, dovete fare uno dei due microfoni.
Adesso si ridotta l'eco. Se no la prendo dalla presentazione.
Io ho tutto mutato. Stiamo. Senti, io lo sto facendo con la condivisione dello schermo, quindi sto iniziando adesso.
Ok.
Mi devi dire se si vede bene.
Devo andare full screen.
Riesci a dirmi se si vede, se posso iniziare? Okay. So, welcome to this presentation. I'm Riccardo Bruno from NFN in Catania, and currently working for the Indigo Data Cloud project. This presentation is about the Feature Gateway, and the points that will be covered during this presentation are, of course, an introduction of the Feature Gateway system, how it is implemented in the context of the Indigo Data Cloud project. Some words will be spent on how this system is managing the authentication and authorization. And then I will show you some of the APIs provided by this system. Few words will be spent also for the installation, and if the time is enough to continue, I will introduce also the database structure of the Feature Gateway. So let's start with to introduce you on the Feature Gateway. Shortly, the Feature Gateway is a framework aiming to build science gateways. So maybe many of you have already an idea of what Science Gateway is, but I like to show a definition that has been written by the TerraGrid XED project, where it says a Science Gateway is a community-developed set of tools, applications, and data integrated via a portal or a suite of applications, usually in a user interface, and further customized to meet the needs of a specific community. So I like this definition because it highlights some of the important points of a Science Gateway. And those points are the community. So it must be a system aiming the community to work and cooperate each other. We have the presence of tools, applications, and data, and the integration of those. It provides a graphical user interface, so it is important to provide to the users web interface or desktop applications or mobile even. And then the word customization, I would say the most important one, because by the experience, we noticed that any community has its own tools, has its own web portal, and it is important for existing communities to provide customizable things. As I told you, the Feature Gateway is not starting from zero. It's an evolution of another product that we called in the past the Catania Science Gateway Framework, aiming still to create the Science Gateways. So let's see some of the design principles. So the first point, the Feature Gateway provides, as most as possible, an easy way to install it and also maintain in the time the system. So we have installation scripts at the moment. We are planning to have also Ansible roles for cloud environments, and also in the future we hope to have also Docker container installation. All the source codes are available on GitHub, and the software design itself is thought to be highly customizable, just to just to allow different communities to satisfy their needs. It provides, as a second point, a flexible and uniform access to distributed computing services. What does means? Under the hood, the Future Gateway is using the so-called JSAGA library. That is a library aiming to access with a single set of function calls to interact with the grid and also cloud infrastructures. In the context of the Indigo Data Cloud project, beside the JSAGA, we are also providing the access to the Tosca orchestrator. That is a system that helps to create on-demand platform as a service infrastructures in a dynamic way. And the third point, the most important one, is that the Future Gateway provides a set of API calls in the RESTful format. So this is an important point because with the use of REST APIs, it's possible to have to reach the portal independency. So any community can use its own portal technology. It is possible also to deal with mobile and desktop applications, and RESTful APIs can be also used by any programming language. So in this, with the use of RESTful APIs, we are targeting the customizable thing I told you during the description of the Future Gateway. Some important concepts in the Future Gateway. This system is managing three entities. On the top, we have applications, so something that will be performed on the distributed computing infrastructure. The second component is the infrastructure itself. The infrastructure is a description of the distributed computing infrastructure, I mean a cloud infrastructure, a grid infrastructure. And so with the infrastructure, I'm describing which is the security mechanism used in this infrastructure, how the application will run on this infrastructure, etc. The task is the third entity, is the instance of an application. I mean, we used the word task instead of saying jobs as it happens on the grid environment, because with the Future Gateway, an application can be many possible things. A task could be a simple batch execution running on a cluster, or a task could be also a job that runs on a virtual machine started automatically. Or in the case of the platform as a service with Indigo, with the term of task, I could mean that I create several nodes, and those nodes will start a batch execution. So the API provided by the Future Gateway are written in their specification, are available on the Future Gateway API website. We are using a web tool to describe the APIs, and we are using API. And as I told you, the APIs are managing exactly the three entities I described before: so the tasks, the applications, and the infrastructures. And we will see later how the APIs will manage those entities. By this slide, we can see some of the usage scenario that the Future Gateway framework can offer. So on top of the slide, we have the final users. or final users using mobile and desktop application. Below, on the left side, we have the a scenario like the Catania Science Gateway Framework. That means we have a LifeRay portal and several portlets inside providing a GUI for some applications, and below the API server provided by the Feature Gateway. So this is exactly this scenario on the left provides exactly the same scenario of the Catania Science Gateway Framework. On the middle, we have an existing community portal, and you can develop on it portlets or web applications. Let's imagine Tomcat with its own web applications. Or you can even use flat web technology and with Ajax to provide queries to call APIs provided by the Feature Gateway. So in this context, the Feature Gateway is its external component, and the community portal communicates with the API server, and the API server will interact with the distributed computing infrastructure. In the case of a mobile and desktop application, the connection could be a direct connection, but in the phase of authentication and authorization, you need a service named PTV. And I will show you later, I will give you information about this service later, so you will understand better what happens during the authentication and the authorization phase. So the Feature Gateway is composed by three elements. We have, on top of all, a database that keeps and maintains during its lifetime the information about executed tasks, installed applications, which are the infrastructure used by the application. Then it manages a queue of tasks, and we will see later how. And finally, it manages users, groups, and roles. The second component is the API server front-end, which accept APIs, the calls provided by the users, fills a queue table that corresponds to the command. It also is responsible to manage the authorization and the authentication. It is responsible also to manage application tasks and infrastructure. And in this scenario, more front ends could exist. So at the moment, in the context of the Feature Gateway Framework, there exists only one front end named FG API server. Maybe this is wrong, sorry. No, so it's like, okay, FG API server. This is the front end. The third element is the API server only. And this is extracting the tasks written in the queue and execute the command described in the task. It also checks the consistency of the submitted tasks timely, and it is also responsible to retrieve the output if the executed task produced any. So in the architecture design, you may have also more API server. This could be possible for different reasons, from scalability, for instance, or to reach other distributed computing infrastructures. This is a very simple schema. On top we have the GUIs. Then we have a layer, the green layer, with the API, the possible API front ends that are communicating with the database. And below we have the API servers that are extracting from the command queue the tasks, and the tasks are executed on the DCIs that are in the little cloud below, in the bottom of the figure. So let's see the API front-end part. So on the left side, we have a graphical user interface that through the REST APIs is sending a command. So we are starting from the left to the right. This command is taken by the front end, and the front end first verify the authentication and the authorization. So it produces a check. This check could be also done with the external AAI system. Then if the authentication is successful, the command is processed, and you could provide immediately a response, or if you need to update the database, you change the database accordingly. And in case of a task management, you could enqueue the command on the queue table and create the response. So the command and the response are both in a JSON stream format. On the other side, we have the API server. The API server, as I told you, is extracting the commands from the queue, and inside each command there are two elements. There is the action, so what you are going to do with on the DCI, and a name that corresponds to the so-called executor interface. That means the element that the API server will use to physically interact with the distributed computing infrastructure. So at the moment, in the context of Indigo Data Cloud project, there are only two executor interfaces available. The first is called the Grid Engine. It's a small component, a core component of the Catania Science Gateway framework that is using JSAGA to target SSH connections. So let's imagine the access to clusters. It also provides area of CCI, so you can instantiate a virtual machine dynamically and execute an application inside this machine, and the classic grid usage with the WMS. With Indigo, we are using a Tosca orchestrator, and I told you the meaning of this component is to create platform as a services, and then also give the possibility to run, to execute something on those platforms. So let's have a look on the implementation of the Future Gateway framework has been implemented with the Indigo context. So on top of the figure, we have the graphic user interfaces available, so web, mobile, and potentially desktop application, but in the case of Future Gateway, also the Indigo Data Cloud project, there are no desktop applications. On the left, we have the FGAPI server database, and the first two components, the other second components that are the front end, that are taking the REST APIs from the GUI, and the API server that are extracting the tasks from the queue table. The API server is, depending on the kind of task to execute, will call the right executor interface. So, for instance, on the left, the Grid and Cloud Engine. the Grid and Cloud Engine will interact with JSAGA. JSAGA provides a mechanism of adapters, and dependingly on if you want an SSH connection or a grid execution or cloud, you can then interact physically with the distributed computing infrastructures. If the executor interface is the Tosca, with the Tosca you can directly connect with the Tosca orchestrator, and the Tosca orchestrator will send the request to the distributed computing infrastructure. So for the code of the front end is available on Git. You can find the web address of the source code. This code is written in Python, and it uses the Flask microframework. And this software implements the API as they are described in the specification site. And this service can run in two modes. The first is a standalone mode, and that means you execute Python and the name of the main file, and this is can be satisfactory only for testing purposes or development environment. But in production, it is suggested to you configure WSGI on your web platform, and we can support you for Apache and Mu WSGI with Nginx. This implementation of the front end is using the MySQL as database, and as I told you, the database is managing the tasks, application infrastructure, user group and roles, and the task queue. The API server daemon is the other component, is available on Git. It's a servlet this time, and it is running on top of Tomcat application server. It's simply a Java application that it's a web application that execute a process that polls the queue table. The choice to write a Java application, a Java web application, is because we needed to interact with the JSAGA JSAGA libraries, and JSAGA is available only in Java. The daemon is extracting the tasks from the queue. It discovers which is the executor interface right for the execution, and calls with the name of the executor interface the proper class, and the class finally will do the interaction with the distributed computing infrastructure. It also provides a timely check in order to see if the executed task terminated or not, and eventually retrieve the output if it exists. Otherwise, it also prompts for errors, etc. The API server daemon provides also a control panel. And the slides shows that this component is not yet consolidated. No developments have been done since the creation. And but the aim of this control panel is to provide and eventually in the future configure the behavior of the daemon part of the future gateway. So let's start now to see how the Future Gateway is currently managing authentication and authorization. So we have basically three methods to manage authentication and authorization. We have the so-called baseline mode. That is a very simple approach. It is very close to how OAuth is working, and we provide this kind of authorization and authentication mechanism for all those environments where there is no AAI implemented at all. So communities that don't have this system can use the baseline or can customize the baseline. Customize means that the code has been written in the way that you could change just one function to have the customization done. Then we have the way that the old platform was using, the Catania Science Gateway framework way. With it is using Shibboleth. The portal is managing the responsibility to manage the authentication and authorization is delivered to the portal. The portal must implement the so-called PTV service, Portal Token Validation, means the acronym. We will see what kind of service provides this PTV. And what happens is that the portal users are mapped with a mechanism with the Future Gateway API users. So you should, in this way, you have the portal users and the Future Gateway API users, and you have to find a way to map those two different kind of users. And finally, we have the Indigo DC IM way that use in Indigo. We have a special case where we are using AAI. IAM. It's another system that use OAuth. And also in this case, it's the portal that manages the authentication and authorization. It still uses the portal token validation service. And again, portal users are mapped somehow with the API users. In the case of mobile and desktop application, again, we should use the PTB service to contacting first the portal and then the API server. It's better to see a figure, and this is explaining this figure is explaining the case of the baseline authentication and authorization. Step number one, the user contacts a login service providing a username and password, and this information will be encrypted with a key. The key contains with this information is encrypted with the information of the username, the password, and the timestamp, and collected in the log token. The log token is then used to start to access to use the API server. So there exists a special REST call for this. You provide this log token. The log token is taken, decrypted using the same key used during the encryption. And with this mechanism, you can identify the user stored on the API server. If the user exists and the timestamp is okay, and this API call of the token check will create as another token that is called the session token. We are at the point number 3. The session point will be used later for any other for any other API call. So if I want to get the list of the task, if I want to submit the task, etc. You are free to use this session token until the token expiration, because it's not, it has a limited lifetime. In Catania Science Gateway framework, we have the user on the left accessing to a web portal, and the web portal is first redirecting the user to an identity provider, and the identity provider provides the authentication. Then the second point, an LDAP system is managing the authorization of any authorized authenticated user. So once the authentication and the authorization
maybe we can connect to this, because there were not any internet access. Connected. Skype is connected again. Okay. Tell Ricardo to call us back.
We are writing.
Okay. Now we are on. Sorry about it. Is he calling?
Abbiamo stoppato la chiamata, se no lui non si accorgeva di niente.
Pronto? Which is the last slide you have seen?
Sto leggendo tutto. No. Dove? No, che si sta vedendo? Ma no. Che cazzo ho scritto, vabbè, non ci sento.
Okay. Put the slide.
Do you see the slides actually? Do you see my screen? So So we'll go back here, I think, in Catania Science Gateway case. We have a user on the left that contacts to a portal. The portal redirects any user request to identity provider service that provides the authentication of the user. Once the user is authenticated, another system is providing the authorization with the LDAP. Once the user is authenticated and also authorized, there will be produced a token in the step 3. This token, each time a REST call is provided to the API server front end, a call to the portal token validation service will be given, and the aim of this call is to check the validity of the token. If the token is valid, the API server can process the request. During the Catania Science Gateway framework, we were accessing the resources using the eToken server service. This is a service that creates robot proxies needed for all those infrastructure using the GSI security mechanism, the grid security infrastructure. In the case of Indigo, the service, the system seems similar. We have the so-called IAM service that provides both authentication and authorization, and it replies during the login phase with the portal with a token. This token is also used to access the API calls, and again, each incoming token will be checked with the portal token validation service. And if the token is okay, the API server will process the request and bypass the token to the resources. So IAM tokens are also used to access Indigo resources. But let's see now what is exactly the portal token validation service. A service normally provided by the portal, and the aiming is really simple. It just verifies or get fresh tokens. In order to conduct the portal token validation, you need to configure the HTTP basic authentication method, and just encrypting the username and password with a base 64 and placing it in the header of the request. And those settings are configurable parameters in the configuration of the API server front end. So the services are verify an incoming token or get a new fresh token. So in the case of verify, you have to provide a post request providing the token on the token parameter. If the token is okay, so you receive a successful answer, and you also receive the field subject that identify uniquely the user associated to that token. In order to get a new token, a new fresh token, you have to create a post request specifying just the subject. And as a result, you will receive a successful token, a new fresh token. In the case of Indigo project, the PTV service is provided in the form of LifeRay IAM. It's a service developed on top of LifeRay 7. So in those cases, you could recycle this. But we have other use cases where the PTV has been implemented from scratch, and there is one of the use cases is molecular dynamics is implementing it in Python. So soon their source code will be available as well. So the implementation of the feature gateway so far are at the beginning of the Indigo project was published the demonstrator, and the molecular dynamic project was presented during Cloudscape in February 2016. Then during the first review of the project, some interesting use cases were presented for climate change, showing how the Ophidia system, that is a kind of architecture to compute on big data sets, and Kepler is another system to manage workflows. So this system was integrated with the feature gateway to execute using the APIs. And also another use case is using Galaxy, is another workflow management system integrated again with the feature gateway. And in this case, they are also providing some interfaces with mobile applications. So let's start to view the APIs. So the main aim of the feature gateway APIs is the task management. So as I told you, the word task is a generic word that can imply the running of a job, deploy a virtual machine, or instantiate a platform as a service, execute a job inside the virtual machine, etc. It could also a data activity can be included in a task format. So the API manages the task entities in the form of the task, that is an instance of a described application. Infrastructure is the where the application can run, and then the management of user groups and roles. So the logic, so the tasks are a task application instance. Application define an executable or an infrastructure. An application may need input and output file or create output files. So you must have a way to describe those entities. Application also accept arguments. And at the end, when you describe an application, you need to describe where this application can run in the form of the infrastructure. Infrastructure is a set of key value pairs that are used by the executor interface to finally interact with the distributed computing infrastructure. In the case of JSAGA, for instance, you are defining some input parameters needed by the JSAGA adapters. And in the case of the Grid and Cloud Engine, we are also providing information to address the e-token server parameters. So the way the system can generate a robot proxy on behalf of the user. So in the case of Indigo, we have configurable parameters to manage the task orchestrator. Maybe later there is an example if we have enough time to reach that part. So the information about the users, group and roles, we have that roles, so what the user can do, are assigned to a set of groups. the users are finally assigned to groups. So in this way, you can assign to the users certain privilege or deny other. So each time an API call is received, during the first check, it is also controlled that a user can execute the API, the specific API call or not. So during the API description, I will use some convention. I'm using the curl command to explain the APIs. Curl is a well-known command. It's also very helpful during test and development phases. In the examples provided, I'm not including the tokens, just for to be more clear in the explanation. But for the token management, what you have to do is simply including the token information in the header section of the request. During your own tests and development, I recommend the use of the JQ command line tool. If you don't have it, you can install easily in any operating system. JQ produces a JSON output format in a human readable way. So you can see colorized field parameters and so on. You can even use other tools to execute APIs. There exists also Postman as a graphical user interface, a web graphical user interface to do exactly the same things of curl. So this is on top. You can see a typical curl execution. So we have curl minus h specifying any parameter in the header section of your request. Optionally, you can provide some curl options for verbosity, for instance. Then with the minus x capital, you can specify which HTTP method you are going to call. This method could be get, post, patch, or delete. Then the address of the API, you want the API, so the Future Gateway host, Future Gateway port, the version of the API you are going to use, and then the action, and optionally some filter parameters. Input and outputs are in JSON format. The output contains also a special field named _links that helps the user to, or even the GUI, to automatically generate possible answers. And okay, the basic line AI use tokens. Okay, and for instance, at the bottom of the slide, you can see how you can specify, for instance, a token during the execution. So minus capital H, then authentication, colon, bearer, and then your token. This is the way that the API server uses to send the token. In the API call, you can also use filters. Sometimes, for instance, to get the list of tasks of users, and with the filter, with the user filter, you can impersonate even other users, dependingly if you have this role or not in your roles. So, for instance, when you are listing all applications or tasks, if you specify user equal to star, you are going to see the tasks of any user in the system. Or if you would like to see the tasks of a particular group of users, you can even use the monkey character, so you can limit the visibility of the API call just to a single group. In order to use this filter, you need special parameters, special roles, and those are the user impersonate and group impersonate. Normally, if you are not using, if not specifying a user in the APIs, a user in the filter, I mean, the API server will use a default user. Otherwise, it tries from the token to extract the user information, and the visibility will be from the user owning the token. Let's see the first example, how to list all tasks. So just execute curl, HTTP, specify the host, the port, the version, and then tasks. And this replies with a JSON containing under the keyword task an array with several task records. So you can see the internal ID number, then which is the user, the status of the task, the description, date, which are the input files, the output files, which is the application identifier linked to this task, and so on. This call could be used, for instance, just to get the status information. So during after the execution of a task, you can check status with this code. So in this way, you are retrieving all the tasks. But if you want to filter out the answer, you can restrict, for instance, the answer to a limited to just one user. So if you use the filter user equal to and specify the users, and then you can use also the wildcards like star or @ for groups or for all users. If you want to restrict also the answer to a user and an application, you can also use the filters, as you can see in the second step. So you are specifying the username and also the application ID. You can also see the status, the information of a specific task, providing the curl command, HTTP, host, port, the version number, tasks, and then the task identifier. In this case, you receive just a task record containing, again, the same structure. So the identification number of the task, the user who created the task, the status of this task, and so on. How to submit a task? In order to submit a task, you need to provide a curl command executing a post action, and the data of this post action are a simple JSON structure, a JSON stream containing the application identifier and the description of your execution. This is depending on how the application is has been created. This is the minimal set of information you can provide to execute something on a DCI. Of course, in the real world, you can also add other information like input files, where to get the input files, which output file you will receive, etc. But what happens when you submit a task? There are two possibilities. The task is executed immediately, or the task is waiting for further input files. So this is depending on how the application has been configured, because you can specify default files. If you specify those default files, there is a case where the execution can start immediately. Otherwise, the task waits that you provide the input files for the application execution. How do you provide those files? There is this input REST call that again is a post action. The endpoint is the task ID and then input. So in this case, you are just accepting the default output input files. Otherwise, in the second curl call, you are uploading the file needed to execute that application. So the task will start, it will finish after a while, and in the task information, as soon as the status of the task is done, you will find inside the output files the URL to access on the content of the output files. So for instance, you can, in this slide, I'm underlying the file path. And if you cut and paste this path to curl command, so HTTP localhost 888 and the version of the API, and then on the wall output of the field URL, you can access to the file. To delete a task, you have to provide a -x delete as an action, and specifying just the tasks endpoint, and then specifying which is the task that you want to remove. This method is very removes totally any information about this task from the database. So the use of delete should be done only by administrators. Another feature of the task management is the runtime data. So it's done through a patch method, and with the runtime data, you have the possibility to communicate, or I would say to save data produced by the task in form of a record. So the runtime data is an array containing the data coming from the task, and this data is customizable from the application, and it's the fields are the data name, the name of the data that you want to save, which is the value, and the description of this value. To understand this, you may think about a running application on an infrastructure that produce the percentage of its execution. So you can publish this data using runtime data. So in the status, when you get the status of this task, you are updated also with fresh information about the execution in percentage value of the task. One of the latest feature was also to introduce the cancelled status. So the user can change the status of a task. You can ask cancelled in order to remove the task from the execution. This completes the task part of the PI. And then we can see the part related to application management in a very similar way. In order to get the list of all applications, you have the endpoint applications. If you want to restrict the list of the application to a particular application identifier, you can get the single record with the application and then specify its identity number. To install an application, you need to specify a post action. The data related to this post action is again in JSON format. You can see here an example. We are creating an application that creates a job. So you see outcome is a job and it's not an infrastructure. A description of this application, the name, if this application is enabled, and the parameters used by this application. And inside the parameters we have the description, for instance, which is the target executor, which is the executable, etc. And then the infrastructure section where you specify the infrastructures. Some notes. You have seen that I'm specifying in the example infrastructure inside the application creation. This is still acceptable, but from the newest version developed recently, you can also specify infrastructure IDs, identifiers. Here you are some details about this implementation, but I think we don't have enough time to go here, but maybe later. I prefer to go directly to the infrastructure management first. In the same way, you can manage infrastructures used by the application to list them. So I want to see infrastructure and then specify the infrastructure ID. Or without specifying the infrastructure ID, I can show all infrastructures. I can install a new infrastructure using executing a post action. So here is an example of a very simple infrastructure with the simplest example I can provide, specifying an SSH access. And in the same way, we have with the delete method the way to delete an infrastructure. So about the API usage, some consideration can be provided. Normally APIs can produced in a web page through the use of Ajax or in other format with LifeRay portlets with all the LifeRay 6.2. In the LifeRay 7 we are still using Ajax. The use of REST API opens to many programming languages and also web architectures. And okay, in case to to access infrastructure using the X509 proxy certificate. In the past, we helped the developers to access our infrastructure with VPN access, or to provide a way to access our eToken service. This is an example of Ajax call. So you prepare the URL of the API call under the URL field. You are specifying a post action. This is an example of task execution. And you can see this example inside the hello tester, inside the specified Git address. Here are some consideration about the creation of LifeRay portlets in the context of LifeRay 6.2. So you have several steps described how you get started with portlet development. In LifeRay 7, the environment has changed, so there is another way to create portlets. You are using a single executable named Blade, and there is also a link to the documentation of this new way to create portlets for LifeRay 7. So on the other side, we are also starting to think in creating some libraries for the most popular languages, Java, Python, and PHP, for creating high-level classes that are hiding the APIs. Maybe this could be also useful for developers, especially for those using desktop and mobile applications. And finally, we are in the installation of the Future Gateway. The installation, everything you needed for installing the Future Gateway is available on Git. And here you are a Git address. Maybe I will change this slide because it's not the Indigo link, but the link works as well. There are the installation scripts are split in different kinds of type typology. We have core scripts, and those are the one starting with setup underscore something. And one of these files is one of the most important one because it's the setup config. This file is containing any configurable value that you can customize during the installation. Then during the installation, some files are needed. They are containing libraries and other static content. And the installation can be done on top of Ubuntu 14.04. You have the name of the installation files. And there exists also the installation on top of CentOS 7, if I'm not wrong. And it is not reported in the slide. So maybe I will modify also this. It is also possible to install the Future Gateway on top of the AG-Fed Cloud. I don't know if the AGI-Fed Cloud has been described before, but shortly the Fed Cloud is an environment where registered user can deploy virtual machine on demand. So without caring where they are running or not. So you just access to a virtual machine from everywhere. So So to install, here in this slide you have this instruction to install the Future Gateway on top of Ubuntu. So the first step is to extract from Git the setup file. Then there is a moment where you need to configure your inside the FG setup file. There is a place where you can specify some configurable settings, and then to execute the script, just execute FG setup with the username Future Gateway, hostname Future Gateway, the SSH port that is configured on that host, and the public key that you want to use. I think it's much more complicated to say in dia slides, but if you, for instance, go on the GitHub page and have a look on the README, everything is much more clear. The same script is also usable on a Docker container. So if you for this reason, a specific script has been written as well. So you can start a Docker container, and executing that script on a Docker container, you will get also a Future Gateway. Here you are instruction on how to install the Future Gateway using the Edge Fed Cloud. You need to be registered to a virtual organization. You need a personal certificate, also a command line tool provided by the Edge Cloud. And once you get all those things, then you can go to the virtual appliance. So that is a virtual machine available for this, and you can execute this virtual machine, and this automatically install the Future Gateway. This is performed thanks to the contextualization scripts. A contextualization script is available for the Future Gateway, and in this slide I'm highlighting some of the important points of this contextualization script, because you need to customize this contextualization script for your purposes. For instance, you can change your SSH key. So you can provide, you have to modify this field, and you can also change the SSH port where the system will be available. You can change passwords for Tomcat, or ask for live installation or not, or if you want to reboot the machine after the installation, and so on. You can even customize other parameters. This is well depicted in the README of the GitHub place describing the contextualization file. And this is exactly in this slide. You have the instruction on how to customize the specific settings that are contained in the setup config. So once the installation finishes, the installation creates also the Future Gateway service. It is available under etc init.d, and you can manage its execution with the Future Gateway start, stop, restart, etc. There are also several considerations if you are configured the API server front end using WSGI. In this case, you have to switch a flag or accordingly. how to monitor the execution of the future gateway. If the standalone, if the front end is running a standalone mode, there exists a screen section. You can go attach to this screen section. You have details about this activity. For the API server daemon, it is running with the Tomcat, so you can, for instance, access to the Catalina out logs, or for the specific daemon logs, you can go to the specified path Catalina home, web apps, web API server daemon, web info logs, and API server daemon.log. And last point is explaining how to access to the API server database. So there is the MySQL string able to connect to the DB. The installation also installs some shortcuts to connect to the database. One is the ASDB, API server database, and the other one is the user tracking database, UTDB. And those are shortcuts just to don't write the long sequence of MySQL -h, etc., etc. They are just connecting and shortcutting the first line. You can also provide an input to this ASDB, for instance, providing an SQL command. And this SQL command will be executed against the API server database. The second user tracking DB, the UTDB, is another database that is used by the grid engine executor interface. So after you are using the automatic procedure to install the future gateway, you can test it immediately, because the system is installed in a way that you can perform some tests. So the first test is the Hello World example. In the slide you have step by step how to do this. So I would like to move to the second example. Hello World, I would say that it's really, as its name says, it's just an example, very limited. It's just to execute on the same machine something. And the second example is a little bit more complex because it provides the classic usage of the classic scenario of a job execution on a remote machine. This example, you have argument for the application, you have also input files, output files, etc. So in this slide you have again examples on how to perform by your own the test on the installed machine with this example. So Hello World and Say Hello are tests that you can perform after the installation. So normally applications are stored on the front end source code and under the apps folder. So you can find Hello World and Say Hello in this directory. On Git there exist other applications that you may see or try to configure for your own needs. They are working in the same fashion. There is a script named setup_app that is the responsible to install the application using the API on the infrastructure. And then call another script named stress test that execute the application on the infrastructure. Then you can collect in this app folder other files that are related to the application input files. Below, from now on, we will see some configurable fields from, for instance, in this case, the API server front end. There is also the description of some of the fields. For instance, at the bottom you have the endpoint for the PTB. It's not the endpoint; it's the mapping file. Okay, but you can set up different values of this service. Okay, the endpoint is the last fifth row. For instance, the PTB endpoint, which is the PTB host name, username, password, etc. And then the second section of the front-end configuration is the related to the database. So you are specifying how to connect to the database. It could be in the same machine, but it could be also in another machine. If you are interested on configure the execution of the front end with WSGI, here you are an example that you can try to use for your case. On the daemon part, the API server daemon stores several configurable parameters in a specific property file, API server daemon.properties, and this is containing several settings. The most important one are the one related to the polling, the queue of task polling. You have, for instance, max number of threads. The close timeout is used when you shut down the daemon. The delay of the polling. So, for instance, 4 seconds for each polling on the task queue. Then the maximum number of tasks to get from the queue for loop, and the other fields. For instance, at the bottom we have the fields needed by the grid cloud engine to access to its own database. So very simple. In order to maintain the Future Gateway in time and maintain it updated with the latest changes applied on the code, there exists also a possibility to keep the database updated during the time. How to do this? There is under the front-end code directories, there is the directory named db pages. This directory contains another script named patch apply, and if you execute it, it will check if new version are available, if you database schema version are available, and in case applies the patches. Of course, this is very the user must be very careful executing this kind of action, and it is highly suggested to verify the log files produced during this action. By the way, this mechanism allows to database schema, and accordingly it's the code of the Future Gateway during its lifetime. To update the code if it is enough to update, to check out from from GitHub the new source codes. Okay, these, for instance, are the instruction in this slide on how to update the system from source code point of view. So go to the directory, eventually to the adapters directory, extract the new code with the git pull, and in case you are updating the Java component, I mean the API server daemon, you have to compile again the application file, and the produced Word file must be placed in the Catalina web apps application, and then it's suggested to check the log files for errors or if everything is fine. In the same way, the adapter are working. In case you are updating adapters, you have to first update the adapters and then copy the produced library inside the API server daemon, the library directory, and then recompile the API server daemon. So I think I would skip the database section because it's a very specific. Maybe the time is not enough. What do you think?
Before we break and go to lunch, I want to make a comment. So, first of all, if you have questions to Riccardo. Not. Okay. So, the future gateway will be one of the most important components because, for example, we are discussing some scientific applications. So you will get the application integrated on a web app, but then you will be using the future gateway to submit actually and make the application running on a cloud or on a grid or on a high-performance computing cluster. So the future gateway, and we have all the materials and documentation. So the slides are on the web. But of course, you will be, according to what you will tell us on Wednesday, we will support in developing your application. So I think if you don't have any other comments or questions, I would break here for lunch. What time is it? It is 1:30, so we can reconvene in 1 hour. Or 1 hour 15 minutes, just to be safe. So 2:45, we reconvene. We will be running an hands-on on the future gateway, and then there will be another presentation on, we will start touching data, actually metadata. So we will be a presentation and an hands-on on the metadata catalog. So we will reconvene here 2:45, okay? So we can close this and we see each other again at 2:45.